Green checkered shirt. Okay, fine. Polygons and angles. Yeah, we're going to talk about the angles that are inside polygons. And polygons, if you don't remember, polygons are a closed figure with 3 or more line segments. That's these. So one of the things we're going to do is, what we have is a knowledge of the understanding of this. We know that some of the angles of a triangle equal 180 degrees. And because that's the case, if we can take polygons and divide them into triangles, or as many triangles as we can make without crossing the lines, we can determine how many angles are in that. So if I take this and I just bisect my rectangle here like that, how many triangles have I made? 1, 2. Therefore, this triangle has 180 degrees, and this triangle has 180 degrees, which means there are 360 degrees in the angles of that rectangle. Now, you're sitting there going, I knew that, Mr. Romanovich. There's 4 90s here. Let's look at this one then. Showboat. Let's make as many triangles as we can from this vertex. So I can make this one. I can make this one. I cannot draw a line to this one, I already have. I cannot draw a line to this one, I already have. I have 3 of them. So that's 180, that's 180, that's 180, which means that the number of angles in this shape are the measure of all the angles in this shape. What that means, oh boy, let's be clear about this. That is this angle plus this angle plus this angle plus this angle plus this angle is 180 times 3, which is 540 degrees. There's a pattern here, and from that pattern we're going to figure out an expression, and we're going to do that right now. Let's look at a possible pattern here. So now I've got a chart here that we're going to fill out, and let's see if we can figure out what that pattern is and put it in here so we have something applicable to any polygon that we could run into. Alright, so I've got, let's go back to what we know. We've got a 3-sided figure. Here's a triangle for that 3-sided figure. We know there's one triangle, which means the sum of those measures is 180 degrees. That is the law. That's geometric law right there. Then I've got a quadrilateral here. There's 4 sides. 1, 2, 3, 4. I can bisect that and turn it into 2 triangles, which means I have 2 of those triangles, so that's 360 degrees total. Here I've got a 5-sided figure. 1, 2, 3, 4, 5. It says it right here too. I can make that into 3 triangles, and I did the math in my head on the last page. That's 540 degrees. And then I got 6 sides. 1, 2, 3, 4, 5, 6. And I divide that up. I can get 4 triangles out of that. I'm going to add 180 to this. 640 plus 80 is 720 degrees. Now, let's look for a pattern. How is my 3 becoming a 1? How is my 4 becoming a 2? How is my 5 becoming a 3? How is my 6 becoming a 4? What do you notice? Teacher wait time, teacher wait time, teacher wait time. Yeah, so we're taking the number of sides and subtracting 2. Number of sides minus 2. Then we're getting a value. Now, how do you notice this is changing here? So let's go with the blue. How does that become that? How does that become that? How does that become that? How does 4 become 720? What do we do each time? Yeah. We knew how many triangles are here, so we multiplied by 180. 180. 180. 180. 180. That's pretty simple. Now, can we turn this into an expression? And what we don't know is we won't know how many sides we have ever. Because whatever shape they give us, we've got to count the sides. So we're going to make this our n. And we're going to say n. The number of sides, and n is equal to the number of sides of the polygon. Okay? Now, what did we do to n each time? I have to get my eraser. Oh, good. I already started it. Sorry. Oops. We subtracted 2 from it. So we took away 2. And then what did we do then? You're right. We wrote it. We multiplied by 180. That's not right, though. Because we multiplied the result of n minus 2. So this is the thing that needs to go in parentheses. Now that's legal. Parentheses n minus 2 times 180. But let's write it in a way that's a little bit easier to read. So what I really want to do is I want to do 180 times the number of sides minus 2. And that will tell us the measure of all the angles of a shape. Let's look and see what that looks like. First thing, let's write the formula that we're going to use. We're going to use 180 degrees times n minus 2. And what we know is that n is equal to the number of sides. Number of sides. How many sides do we have? For me, it helps to label them so that I can remember where I started. I've got 6 sides there. If I have 6 sides, that becomes my n. So I've got 180 times 6 minus 2. 180 times 4. This polygon has 720 degrees of angles. It's 6 sides. 6 sides is a hexagon, Mrs. Benoit says. Hexagon. That was it. Let's try another one. These are kind of fun. I'm going real fast, so speed round, lightning round. Just going to erase and go. Erase. Next slide. Quick, 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 quick. Heptagon. There's not even a picture. Where's the picture? We don't need a picture. Look, it tells us. There's 7 sides. So if there's 7 sides, I'm doing 180. And then, oh, I better write this down. I've already kind of forgot it. 180 degrees times the number of sides minus 2. So the number of sides is 7. 7 minus 2. 180. That equals 7 minus 2 is 5. And then, you know, the measure of all those angles, measure of all angles is 5 times 180. All right, some side math. Let's not fool around here. 5. Wait. Yeah. 0. Carry the 4. No, I'm early on the 4. 5 times 8 is 40. Carry the 4. 5 times 1 plus 4 is 9. There is 900 degrees categorically in that figure. No matter what, I guarantee you there's 900 degrees. We can do that. Let's do one more. Come on, rapid fire. Here we go. Erase, 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 erase. I even erase the formula. Even though I'm going to the next page, I'll write the formula. 32 gone! How many sides are there in a 32 gone? I bet you could guess. All right, I'm not going to tell you yet because you have to guess. You haven't guessed. Disappointing. N minus 2, 180 degrees, a triangle, times the number of sides minus 2. A 32 gon has, here's my tip for you, 180 times 32 sides. So at some point, mathematicians decided to stop picking out Greek letters or numbers to represent the number of sides in a shape, and they just said, just write the number and put gon on the end, and then we know it's a shape. So we got 32 gon, and we're going to do this math right here. So now I've got 180 degrees times 30, and I go off to the side here, and hopefully you picked a spot where you have room on your paper. 0, that's my annex 0 there, and then 3 times 0 is 0, 3 times 8 is 24, 3 times 2 plus 2 is 5. Wow. The measure of all those angles is 5,400 degrees. Okay, last one. Okay, let's put this in practice and add a little bit of algebra to it so we get a little practice again. I've got we need to figure out what x is. X is the measure of two of these angles. And then 5x is the measure of the ones that are not x. And if we remember right, it's 180 degrees times the number of sides minus 2. There is 1, 2, 3, 4 sides, which means I've got 180 times 4 minus 2. 180 times 2. The number of degrees in this thing is 360 degrees. That's good. So you probably knew quadrilateral 360, that's fine. Now let's figure out what each angle is. And we do that by saying the sum of these 4 must equal 360. So I've got x plus 5x plus 5x equals 360. Let's combine like terms. If it helps you, don't forget that there is a unwritten one that is ahead of those two, so we're just adding up x's. 1x plus 1x is 2x. 2x plus 5x is 7x. 7x plus 5x is 12x equals 36, Now we are dividing by 12. Let's get that x by itself. And we get x equals 30. Are we done? No. But I'm going to write the angles onto the figures so that it's easier for us to see. If x equals 30, the measure of this angle is 30 degrees. The measure of this angle is 30 degrees. The measure of this angle is 5 times 30, which is 150 degrees. And the measure of this one is the same, 150 degrees. Okay, if you have questions, please ask. Good luck.